All right, welcome everybody to a fantastic, beautiful, cool Fresno fall day where we are going to learn computer science. Specifically, I'm going to go over some topics that will help you do your homework assignment today. So we're not going to learn necessarily anything new, but it should be useful. So hopefully you're on board for that. So what I'm planning on coding today is something similar to Pokemon that's not Pokemon, so that you can kind of, because I don't want to just give you the answers. What's the fun in that? You know what I mean? So if you guys have any ideas for a topic that we could build a class describing some sort of object, and then we can load that class from disk, then I will implement it for you. Now let's not do a video game, because I was checking my rate my professors and got a negative review. He always talks about video games, which, to be fair, is true. So, but one of the reasons why I like doing it is I'm a video games professor, and you teach what you know and what you love. But B, also the skills for loading Pokemon from disk work just as well if you're in a grocery store loading bananas from disk. You know what I mean? So, the technical skill, to me, it's a lot more interesting to re-implement Pokemon, which is an actual real life task, than to do these little toy assignments, write a palindrome detector. How often, you know what I mean? In real life, how often are you going to write a palindrome detector? It teaches you a little bit about for loops or something, but for an actual homework assignment, I want people to have useful skills that are, the core. I want you to have the core skills. Can you read from disk? Can you make a class? Can you search from a database, to find something? And for the assignment, fair enough. It's it's Pokemon, but the data for the Pokemon assignment comes from, I scraped it from a website. So I actually just went onto a website and just downloaded the data files, and that's actually something I've done in my real life career as a programmer. Because I have not always been a professor, I actually worked as a professional programmer for a long time, and still do technically. I have my own business, and that's actually a fairly common thing. Somebody has a data set somewhere, maybe for example, I worked for the College Board. You guys know the College Board? They do the SATs and AP tests and things like that. So I worked for the College Board, not directly. I was a consultant, and I was given the AP test data for every student in San Diego County, and that's a lot of data. Every student, every test, every school in San Diego County. That's a lot of data. Something I don't know, for years of data. I don't even know how many records it was. It was maybe 100,000 or something. I don't know. It was somewhere in that ballpark. And so my task was to draw conclusions from it. That's the best way I can put it. It's how's it going, AP test data? There's a lot of interesting questions you can ask a data set like that. How many women are taking AP physics versus men? How many men are taking AP Spanish versus women? How many Hispanics are taking AP Spanish versus non-Hispanics? How many, you know what I mean? If you look at economically disadvantaged people, how is their performance comparing to people that are not economically disadvantaged? And does that change based on the test? Are there some tests where they do better and some tests where they do worse? There's a lot of questions you can ask, and it's a lot of data to process. So, this thing we're doing with Pokemon, which, okay, yeah, sure, it's a video game. And if you guys want, I have some perfectly valid heat transfer physics simulations and things like that we can do instead of Pokemon. So, I'm not going to cancel the Pokemon assignment because you guys are already into it. But for your next one, if you want to do a heat transfer or fluid dynamics, we can do that too. It's fine. There's no video games in that. I was a data analyst for the College Board indirectly. The money came from the College Board to pay for me, but I was not working for, I was not on their payroll As a person, I was a company working as a, it's called an evaluator for a grant that was funded through the College Board. That's the best way of putting it. So, yeah, and physics simulations are fun. We can do more with that, or we can do Battleship. Like, to me, like, games are just like a great way of, like, you have to know the fundamental skills of computer science to do them. Okay, so yeah, we can do like church attendance. Sure, yeah, that's actually something I've done before. I've done attendance processing programs, and yeah, sure. Okay, so let's do that. Then main.cc. Ooh, line box intersection. Yeah. Main.cc to public line box intersection. So that's to determine if you have a rectangle and a line, if they hit each other. It's kind of fun. Okay. So, and we'll just use a vector. There's other types of data structures you'll learn about in CSci 41. For now, let's just do this. So we'll do a struct for church person, attendee, person. How about that? So Cromwell, when you're doing attendance for people at your church, how would you describe the people? Spiritual? Wait, no. Like what attributes does a person have that we need to keep track of in our database here? Adult? Yeah, okay. That's a good one. So we can have an enum class called person type, and we can have a like baby or a child or a teen or an adult or geriatric, something like that. And so each person can have a person type that is their age category or something. Okay. And so if you wanted to, for example, send out an email to all of the babies, and obviously the baby's email would be the parent's email, you could say, search through the database. In this case, a vector. In reality, you'd be using a different data structure. But search through the database to find all babies, and then send an email to them. Hey, by the way, we've opened up a new nursery at our church. It's isolated acoustically from the rest of the church, but it's got a speaker so you can hear the pastor talking. Yeah, understand? And worshiper and childcare. Oh, that's true. Yeah. All right, so I use you could use an int. You could just be like int worship type. Is it, or 1 if they're worshiping and 2 if they're in childcare. But an enum lets you enumerate all of the possibilities for that type. So an integer, you might say, well, 1 is they're attending worship and 2 is childcare. But what if it gets set to be 20? Your code's probably not going to handle it, right? And so with an enum class, you can actually specify all possible values that a variable could have. So for this one, we could have worship and 1 for child. Okay. Spends 3% on the nursery room, 80% on the big building, and unnecessary high-quality sound systems. I don't know. I mean, nursery rooms are actually, like, as somebody who went to church with a baby, it's really nice. It's actually really nice because, like, normally, like, if your kid starts crying, then you're like, do I try comforting him? It's not working. And everyone's staring at you. You're like, I'm so sorry. Or you're in a nursery, the kid can just start bawling. You just pull out bottle and stick it on them and feed them, and they're going, doesn't bother anyone, you know. When they get a little older and they're like these dopey little ones and twos, they could just like kind of run around, and you know, if you turn them loose, you know, in the church that way, like people would give you the stink eye. But you know, when you're in a nursery room, like they can just be like, and they can, you know, suck on their pacifier and touch all the things, and it's actually they're actually really nice to have. Age ranges for each group. We could have age just be like manager or a double or something like that. Okay. What other things? Actually, this is actually going to a different structure. Because do you see what I mean? Like, what just happened here? Struct. Is it a tendence or tendence? Whatever. And then we can have a date, maybe. The date could be something like that. I'm just typoing all over the place. Look at this. Okay. Guest versus regular attendance. Yeah, okay. So do you understand why I didn't put attendance type into person? Because a person record describes a person, right? They're not a date of attendance. You know, a person is a person, and so probably a person needs to have like a name, string name, address, social, maybe, I don't know, for tax records. Email, yeah, it's a good one. Name, address, email is an important one. Email. Are they guest or not? Bool. Guest. Who's in their family? Oh, that's a good one. And so if we want to have the family members, then that would be a vector of strings called family. I created a variable of person type and called it age. That is correct. And so age has to be either baby, child, and maybe I'll call this like age category. That makes a little sense. So are they a baby? Are they a child? Or are they a teen? You know, that kind of stuff. You know, or we can just store age as a number, and then we could select based on age ranges and things like that. But this will be interesting. This is an interesting thing here. What if we make it a vector of persons? Well, then it's recursive, right? So a vector of persons, each person will have a vector of persons, and so yeah. What we want, because we don't want to actually have the complete record for a person's kid in there. The kid will have their own record for person. So all we really want to do is just have their name, and we're going to make the name the primary key. So the name, or maybe the social will be the primary key, if we have that. So primary key means what you use to search for people. Like how you're gonna sort the database. And if it's sorted by social security number, you'll be able to find people based on social security number very quickly. If you sort it by name, then you'll be able to find it by name very quickly. Okay. So you guys tell me, what should the primary key be? Should be name or social? Because you don't always have the social. And not everybody has a social number either. I'll do. S is in? Okay. All right. For this, for a business, you know, you're probably going to have that, at least for your employees and things like that, right? Names can be similar. Yeah, you can have duplicate names. A primary key cannot be duplicated. That's one of the requirements for primary keys. You can't have two of the same. And there could be two Bob Joneses, you know, in your church. So yeah, social is a primary key. It makes sense. Name does make sense, like, especially because you're not going to have socials for everybody. You know, like you go to a church, when somebody signs into the guest register, they're not going to write their social down. You know what I mean? So, yeah, this will be this would be hard to do in practice. As it is, this is a toy application. So, assign each attendee an ID number. That's true. You can assign them a temporary social. That's true. That's very true. Phone number, yeah, that's a good one. I'll just save the phone number as a string also. Drone phone number as a string, simply because there's a lot of different ways you can type in a phone number. And I don't want to get into that right now. That's a whole day in and of itself. So you see what we're doing here? We're like describing the attributes of a person. Okay, now let's say they visit the church. Then we want to have a record of their visit. And so the record of their visit will have the day, what type of visit was it? Was it for attending worship or was it for childcare? There's something rather important missing from this. If we're going to write down the attendance record for a person, what's missing from the attendance record? Funeral, huh? Yeah. Wedding, yeah, that's, oops. What the hell? Let me pull the keyboard forward, maybe that's the problem. We can have a funeral, or a wedding, or a baptism, or a social event, or a meeting, congregational meeting or something like that. There's a lot of things. And you see how you just add to the the type there. It's really nice. Exorcism. Who is attending? Yeah, that's exactly right. That's, you know, who's attending? Well, let's write that down. So we're going to save that as a unsigned integer 64, and that is the social of the person who's attending. Okay. So if somebody doesn't have a social, then we will give them a unique ID or something. Okay. Probably outside of the range of normal social security numbers. Right? Because there's 9 digits of social security number. So if you give them a temporary ID, you give them 10 digits or 11 digits. You know, something like that. So they don't conflict. Okay. So I think this looks pretty good. Now we're gonna have to make a data file that we can load from. So let's just do the people first. I don't want to type all this. It's a lot of stuff, isn't it? All right, so let's go into Excel. And we're going to have age, category, name, address, email, phone, SSN, guest, and then a list of family members. Family. Okay. It's gonna be brutal. All right. So age, category, name, address, email, And so you can do enums in Excel. I don't remember how, though. Oh. Okay, so Bill 1111 East Main Street. Kearney. Email of kearney@kearney.com. Phone number of area code 559-204-9761-9871, whatever. Just typing in numbers. Social security number is, of course, 12345. This is supposed to be unsigned in, so 123456789. Guest is false, and family I will just leave empty for now. And then for age category, let's see if I can just remember how to do an enum in like here is a Excel spreadsheet I made for keeping track of my Legend of the Five Rings plays. So I have a little drop down here that selects between the different options. How did I do that? Pick from drop down lists. Okay. It just does it automatically. All right. There's some way you can set up like a list of options to pick from. I'm just going to go with age category of 1, 2, 3, 4. I'll be in age category 4. I'll just do it that way. It's simple enough. Okay. So let's do a couple more people. So toss out some. Go to tab data validation. Okay. Thank you. Why is family an integer vector? It's not an int vector. It's a vector of unsigned integers. It's going to be a list of social security numbers of people that are in our family. And then we can use the social security number to look up them in the vector. Aubrey, 9 months. All right, sure. So that sounds like a baby to me. Name is Aubrey. Address is 222 West Main Street. Let's pull this out a little bit. Email address blank. Phone number 559 205 5134. Social security of whatever 5, 6, 7, 8, 9. Guest, not a guest. Okay, and then we'll add in, she's watching class. Hello, Aubrey, how are you? Be a good baby. Be good to your mom. I'm watching you. Why is age category a number and not the actual name? Because I forgot how to do a enum in Excel. It doesn't matter. We're going to be importing into C++. So this is just Excel. There's absolutely no connection right now between Excel and our code there. We have to write a program that will import from a file into our thing. And so step 1 for Pokemon is you have to describe your Pokemon. In this case, we're doing church attendance records, so the first thing we have to do is describe a person. So let's do an adult for Margaret. Her address is the same. Email is margaret@margaret.com, of course. Phone number is the same as the kiddos. Social Security. Sorry if that's your actual Social Security. That'd be a hell of a coincidence. And her family would... Ooh, that's... yeah. You... Format cells... Text. Really? There you go. And then Aubrey's family has Margaret in it. Sounds like, yeah, it's the Church of Personal Identity Theft. It's exactly right. And then we've got Bart, who is probably a geriatric at this, Bart Simpson. Now he'll be a teenager or whatever. Well, Bart Simpson, who lives on 134 Springfield Road, no email address. Social. Is a guest. No family. Church of UC San Diego. All right, give me 2 more names, and then I'll be done with this charade. I just want to have enough data that you can see whether the code is going to handle it properly. Johnny Johnson. That's literally the name of the second ACM president, or the third ACM president here at Clovis Community College. His name was John Johnson. His dad's name was John Johnson. John, son of John, son of John. Yeah. He went by Chris. Cursed. Okay, so Melody Pond. Oh, is that the girl from Doctor Who? Is that Amy Pond's kid? Melody, yeah. Okay, thought so. So let's make her a child. Why not? Melody Pond. Address. TARDIS Way. No phone number. Social. And she'll be a guest as well. Okay. She's your Halloween costume, that's funny. Was she like the baby in the astronaut suit or something like that? Was that her? Okay, so we'll call this one Fake Church Data. Or Church of UC San Diego. There we go. And so what I'm going to do is I'm going to export this as a tab delimited file to desktop. And yeah, I just downloaded Borderlands 3. It's on sale right now. Oh, I'm sorry. I talked about video games again. Damn. So I'm going to export this as a tab delimited file like this. And so a lot of times you get data just incidentally when you're just working professionally. Like the College Board sends you Excel files, and then it's up to you to like deal with it, all right? Because Excel is actually pretty workable, you know. Cross the line, no more. And so if I open up the text file, it looks like this. So you can see I've got the Excel spreadsheet that has been output as a tab delimited file. It doesn't look quite right because the tabs, let's see, can I view the tabs? View. maybe not in Notepad. But I'm just going to copy this and then go into Putty and call this church of, let's just call it church.text. Less typing that way. Paste it in, and did the tabs come in? Then show white space characters. Set list, is that the one? There we go. And so you can see inside of here that it is showing the tabs between each one, and then that's the end of line. So you see how that's nice? So rather than using cn double right arrow, we're going to use GetLine, because GetLine allows us to read until the next new line. Okay? If I did a cn double right arrow, I don't know if I'm reading from here or if I'm reading from here or what, you know what I mean? So you have to use GetLine to grab and split it based on the tab characters. Okay, so let's do this, because this is probably the hardest part of the homework assignment. So we've got all that. Oh, we haven't even done attendance records yet. Well, either way. $sign means, yeah, new line. It's in Vim a caret. Caret is shift 6. It's the beginning of the line. Shift 4. $sign is the end of the line. Okay. So ifstream ends. What's the name of the file that I typed? Church.txt. Is it a capital C or lowercase c? Lowercase c. Okay. Thank you, Vim, for auto-completing that. That was nice. Okay. And so this is going to open the file for reading. So the first line I'm going to throw away. Why? Why am I throwing the first line away? Yeah. If I wanted to be fancy, I would parse them and I don't know, use them for something. I don't know. Yeah, but yeah, neither here nor there. So this is just gonna, so GetLine by default. GetLine by default reads until a new line character is read. Okay, but you can also have it read until a tab is read. Now, what I'm going to do, I'm going to parse this file one line at a time, and then I'm going to split it based on tab. So what I'm going to do is I'm going to read this line next. I'm going to read the entire line into a string, and that's going to grab the tabs and everything. And then what I'm going to do is I'm going to then split the string based on tabs. And there's a lot of different ways of doing this. Unfortunately, C++ does not have a split function like normal programming languages do, but we can sort of emulate it anyway. So what I'm going to do is I am then going to do while ends. So until we hit the end of the file, I'm going to get. I'm going to grab an entire line, grab a whole record or person, the whole line, and then watch this magic. Stringstream sts out of s. I turn s into a string stream. What the hell is a string stream? A string stream is a string that you can use like a stream, which allows me to do like sts into, you know, something. Yeah. So string stream doesn't like that. Input string stream maybe. No. Might have to include it. There. So you have to include ststream And so basically, if I were to just like, here, let me just demonstrate. While STS string temp. So I can read from this. I can read from the string like it is a string. So I can now say STS into temp, cout read temp, and if an error occurred, then break. So you can see, let me start by printing this whole thing too. So cout read whole line, and remember, cout all of the things when you're doing this. Cout all of the things, just to make sure everything's working the right way. So it's going to read, let's scroll up to the top here. Here we go. So when we run it, it prints out read whole line, and it prints out that entire line, the first line of data, because the header row I threw away, right? So it has for tab Bill Kearney, tab 111 East Main Street, tab kearney@kearney.com, tab blah 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 blah, and then I convert this whole string here into a stream. And I'm just using double right arrow right now, which I'm not going to. I'm just doing this to demonstrate that you can double right arrow out of a string. And so I'm going to read one word at a time out of the string. So it reads for, it reads Bill, it reads Kearney, it reads 111, reads East, reads Main, reads Street, email address. And so the problem with doing double right arrow, and the reason why I'm not going to actually use it, is because you actually don't know where the name ends and the address begins. You guys see that? Yeah, do you guys understand the problem here? Like, I don't know where's the boundary, you know, between one record and the next. And we have a tab delimited file, and so the tabs tell us where one column ends and the next column begins. This is a very common file format. A lot of times you will either have comma separated values or you'll have tab separated values. And either way, you can split the whole thing based on, well, where's the comma or where's the tab? So let's do that. So if I want to read until a tab, rather than using double right arrow, which, like, I won't be able to do the assignment if I use double right arrow, because I don't know where Mr. Mime begins and where the next record begins, you know? Like, how many words are in the person's name? I don't know. 1, 2, 5, I don't know, you know? So you can't use double right arrow. You have to use GetLine for this. So I'm going to GetLine from that string into temp until a tab character is read. Read until a tab character is read. Put the string into temp. Okay. So the first time I do that, the string, it's going to return what the person type, and then the next time I do it, it's going to be the whole name. It's not going to be Bill. It's going to be Bill Kearney. And then the next time I do it, it's not going to be 111. It's going to be 111 East Main Street. It gets the whole column. This here is the key to your homework assignment. Okay. So we do this. Up a little bit. So the first time we do the get line, it just returns 4 because it's for tab, right? Next time it gets all the record, Bill Kearney. Next time, 111 East Main Street, not the entire record, the entire column. Okay? My email address, my social, or my phone number, my social, my guest or not. Okay? You guys with me? And for Aubrey doesn't have, an email address. And so it just reads a blank because there's still a tab there. It just goes tab, and then if there's no email address, it's just another tab. Okay? And so even if you have missing records, they will just show up as blanks when you do it this way. This one has 2 blanks, Melody Pond, you know. And then at the bottom here it says read whole line, And that's because we have a blank line here, so let's get rid of that one. And run the program again. You can still see it's reading a whole line here. And the reason for that is because we're not checking to see if an error occurred. What error occurs? Well, I'll just tell you. If we hit the end of the file, right? Stop when we reach the end of file. Okay. So that right there, we try reading from the file. If there's nothing left in the file, it returns an error. And so that's an easy way of doing it. You can also do if UF, yeah. But that's more typing. So I just do this. This also covers other errors as well. So like if you're on a network share and the network share goes down or something, like you have it at the end of file, but an error occurred. So, you know, this is sort of a general purpose, you know, printer on fire, you know, that kind of stuff. You can do ins UF, but I want the code to break if something else goes wrong, which it shouldn't. It could. There are error codes, by the way, for printer on fire, right? So, high-speed line printers actually generated a lot of friction. Our high-speed line printer, and these things would printed so fast the paper would actually fly up out of the paper like 10 feet in the air, and then it would fold itself into a box. And when we used to submit our programming assignments, they would print them out for who knows what reason. So the entire class of like 300 people, every line of code you had would get printed. And these high-speed line printers could dump the entire thing in like, just like that. And then they'd put a box out in front of the professor's office, and then the TAs would come by and grab a ream of paper, and then they would grade everything by hand, which is terrible. Okay, anyway. Auto grading is way better, trust me. All right. Why is that error code necessary? Because the printer actually would catch on fire sometimes. We had ours in a fireproof room, separate from, and it had a halon, you know, fire extinguisher and stuff like that. Okay, so yeah, errors can occur other than just end of file. So this will handle all of them. Okay. So if we do that, you can see we no longer get that extra thing at the bottom. If you're ever working with files and you get an extra thing at the very bottom, that's probably because you're not checking for end of file after you do your read. So okay. So now that we are successfully reading the data from disk and we are splitting it properly, now it's time to put them into a data structure, right? So for your Pokemon assignment, you have a vector of Pokemon. Here we will make a vector of persons called people. It's a global, it doesn't need to be global, I guess, whatever. Okay, so right here, okay. So right here, how are you gonna do this? There's a couple different ways we can do this. Let's do it the annoying way. Okay, so first thing we do, first thing is to read the person type. String temp, read into the temp, print it out if we wanted, and then we could just do this. If temp is equal to 1, we have to create a temporary person too, okay. Person P, this is the person who will be added to the vector by the time we finish. So when we start off, P is a blank slate, tabula rasa. Okay, so if temp is equal to 1, then we say p dot age category is equal to baby, person type baby. Else if temp is 2, p dot, let's see how this is kind of annoying, p age category equals person type dot child. And there's no getting away from this, by the way, because at some point you have to say 1 means baby and 2 means child and 3 means teen. There's no escaping from having some connection between the number, because Excel doesn't know, it's just a number in Excel, and over here it's an enum type, so you have to build some sort of connection for them. I would probably make a function to do this that takes in an integer and returns the enum type, and vice versa as well. I'm just doing it the kind of annoying way. Else if temp is 3, p dot age category equals person type teen. I should not have made so many categories. Else if p type is 4, then they are an adult, or they are a geriatric. If they're 5, and if it's anything else, die bad age category. And we'll make a die function, void die, taking a string s with a default parameter of bad input. So if you don't pass anything to die, it will just die with bad input. If we do pass a string, like we do here, so we'll just see out s and then exit. If we do, if we do this, then that's fine. Okay. So, yeah. These are all strings, right? Should have macroed that, but that's fine. Or rather than doing that here, because you're going to need to know this. So we're going to get that, and then we'll have int age category equals. How do you convert from a string to an integer? How do you convert from a string to an integer? So we got a string. So we just read from the file, GetLine always gives you a string. Did you guys hear that? GetLine always gives you a string. If you need an integer, you have to convert it from a string to an integer. String to integer. Like that. Crucial for your homework assignment. This converts from string to integer. Okay. And then temp, we'll do CW age category. Like that. Okay. You mad at me? No. So you guys see what I did here? I'm gonna You guys see that line right there? That's how you convert from a string to an integer. So what you're going to be doing for your Pokemon assignment is you're going to be using GetLine. You're going to be using GetLine to grab until the next tab. And then if it's something that's supposed to be an integer, like, I don't know, attack or health or something like that, then you convert from string to integer like this. Are you guys with me? This is really important. So I guarantee that Sunday night I'm going to be getting tons of questions like, I'm trying to store a string into an integer and it's not working. You have to convert it. Okay. The number 5 is not the same thing as the string 5, right? String 5 is just a character holding the ASCII value of 5 in it, which is not the same thing as an integer. These are different types. It's really important. Okay. So then, yeah, we got that. Okay. Are we mad at me? Yeah. Okay. So then, first thing to do is read person type. Second thing to do is read name, address, email, phone. So fortunately, these are all strings, so it's going to be pretty easy to do. Oh, and then we have to add this to the person. P dot age category. Oh, we've already done that. Okay. Yeah. So basically, as we're going along, we're going to be writing into the person. We're creating a blank person, and then as we read from the file, we're going to be writing to the person's name and age and address and things like that. So we can actually do that directly. So we can read directly from the file into p dot name. Get the name, get the address, get the email, get the phone. Done. These are all strings, so it's really easy. For integers, you have to read it into a string and then convert it using stoi. You guys see that? So for your homework assignment, there's only a couple strings for the name of the Pokemon and the type of the Pokemon are strings. Everything else is an integer. So most of your stuff for the Pokemon assignment, you're going to read into a string and then convert it to an integer. But for this one, we're mostly strings. So we got name, address, email, phone. Okay, now we got social. Okay. Third, social security number. So we're going to read into a temporary string, and then we're going to say p.ssn is equal to string to unsigned long temp. S to unsigned long is string convert from a string to an unsigned long, which is a uint 64t. Is part 1 going to be the same thing but Gen 2? No, part 2 is actually implementing combat. So actually having the Pokemon fight each other. It's kind of fun. Okay, so what do we got left? We got 15 minutes left. Making pretty good progress on this. So again, the idea here is you first create the class to describe something, and then you're going to load from disk, and you're going to make essentially a vector holding all the data that was on disk, you know, and then you can do things like searching it and stuff like that. So I'm not doing Pokemon, I'm doing something akin to Pokemon, so you can kind of see the techniques for parsing a file, which is really kind of important, you know. It's kind of, you know, people rarely enter all of their data on the keyboard. They usually load it from a file. And so we've got here a tab delimited file, and maybe over time this Excel spreadsheet gets updated. So all we do is we just, you know, every time we update the Excel spreadsheet, we save it as a tab delimited file, put it on the server, rerun, and it updates. So we got social now. Guest is a Boolean, and so and I always like having comments, just kind of explaining which, like anytime I have a section of code, I like putting a comment just saying this is what this section of code does. Because when you know the purpose of something, it's usually pretty easy to figure it out. Whereas if you read a lot of people's code, they just have a giant wall of code, and you're just like, I don't know what this part's doing. I don't know what this part's doing. What's the purpose of it? If all you tell me is the purpose of the part of code, like this block of code is sorting the numbers. Like, okay, cool. You know, now I understand what you're doing, and you're wrong because you're not using the sort function. But I get what you're doing. Okay, so now we're going to handle guess. We're going to read a string, and then guess, p.guessed is equal to if temp is equal to true. Done. Do you see what I did here? Set guessed to be true if the string read was true. You see, you see that? So every comparison operator returns true or false, right? Less than, greater than, not equal to, greater than, equal to, etc., etc. All of those return a Boolean. And so if temp double equals true, if the string is true, then that expression returns Boolean true, and that gets saved into guessed. If it's any string other than true, then guessed is set to false. And realistically, I could like sanity check it and make sure that it is either true or false. Your dad only comments his code if he knows somebody else is going to read it. Yeah, but what if he's going to read it? Because I forget what I'm doing sometimes too. A year later, like you look at it, and you're like, yeah, I don't know what's going on here. Is temp temp is just a string. Temp's just a string. So I keep getlining. Each column of data goes into temp. Column of data, column of data, column of data, column of data. These I didn't use temp because I could just write directly into the player. I've got a blank player, or not player, person up here. And so I'm setting all the attributes on this person as I read it from a file. I'm reading their age category, I'm reading their name, address, email, phone, social. And for Pokemon, you're going to create a blank Pokemon and then read in their attack and strength and all that kind of stuff. Fourth guessed, and then we got 2 minutes left. And then finally, family. Why did I commit to this? Okay. Fifth is family. All right, so this would be probably a comma separated a list of numbers, and we would have to do another string stream and split it based on commas using getLine. GetLine until a comma. I really don't want to handle that right now, so I'm just gonna assume you only have one family member. Sorry, you can't have more than one family member. So we're just gonna do this. So we're gonna read the last entry, and then we're going to convert it into a number, because your family is your social, the social of the other person, right? So we're going to do the same thing as the social security number up here, right? We're going to read the data, and then we're going to convert it into an unsigned long. And then we're going to add it to the vector. So p.family is the vector. So we're going to add to the vector pushback stir to unsigned long temp. Okay. So in reality, we should be taking this string and then doing another level of string stream, while string stream, get line until a comma. I don't feel like it right now. Sorry. I haven't had enough coffee today. So maybe we could. It's just you don't need it for the Pokemon assignment, so who cares? Adding family vaguely looks like graph. There it is. It's going to create a graph for Seaside 26 people. And then you can traverse that graph. Find everybody that's in the family. Notify them all. Baby Haley is having a baptism. And so you can traverse the family network. Father, grandfather, cousins, everybody that's connected by family. It'll do a graph traversal. And then send an email to each of them saying, hey, baby Haley's having a baptism next week or something. Why is pushback needed? Because your family, the list of family you have is a vector. It's a vector. And I'm not... family is a vector. I'm just not doing the necessary work to support more than one person in your family. But it is a vector. P.family is a vector. So to add a family member, like if you want to add Melody Pond to Amy Pond, you push back the social for Melody Pond into Amy Pond's family member variable. Okay. That makes sense, Garcia? Don Cheadle, whatever. Okay. Is that Don Cheadle? It's hard to tell from the... Okay, cool. Alright. So then, now we're done. We've got family, we've got all the stuff. We've got this person named P that's got all of the data for one row from the text file. So now we need to just add them to the vector of people. So how do we add a person to a vector of people? What's the command? If I want to add P to people, how do I do that? Pushback, yeah. That is correct. So people dot push back P. There's probably some extra error checking and stuff we should do. I'm not doing it right now. And then at the end of the day, when this loop finishes, we're going to have a vector with all of that data from disk in it, and then we can like search it. So we could so if I tried doing this, by the way, like if I get rid of that cout statement there. Okay. So if I tried couting P, would that work? Could I cout the person? Just to see if all the data came in. Because that's my first impulse, right? Like, I just did all this effort parsing, and I've probably got a mistake in there somewhere. You know, I forgot a thing or something. You know. Does C++ know how to print a person to the screen? No. It's not JavaScript. JavaScript's like, I don't know how to do that, but I'll guess. You know, I'll make something up for you, and it'll just print it'll print the class in basically JSON format, if you know what that is. So print a person. Can we do this? No, won't compile. Invalid operands. Don't know how to print a person. So let's teach it. How do you print a person? Well, friend. A little bit of magic here. Just bear with me. So there is, every time you cout something, it calls the double left arrow operator on whatever type it is you're trying to output. And by default, person does not have a double left arrow operator, so it will not print by default, but you can make one. And this is the format. I don't expect you to have it memorized, just, you know, see how I do it. So, this is the boilerplate. This is the template you'll follow anytime you're trying to teach C++ how to print out something to the screen or to a file or something like this. This is the template you follow. It returns an OStream reference. It takes an OStream reference as the first parameter. That's cout. The type of cout is OStream. And it gets passed by reference and returned by reference. And the second parameter is whatever it is you're trying to print out, in this case, a person. And so now we need to print it out. So we say outstream name address email phone SN and just call it a day, I guess. I'm not going to print out everything out. Okay, so now if we do that, then when we come down here, we can print the person out. Actually, I should put everything up in there, huh? Nah, whatever, I don't care. We're out of time. I'm just going to compile it. Invalid use of non-static. P.name, right, because we're printing out the person. P.address, P.email, P.phone, P.ssn. So friend means this function is not actually part of the class, even though it's inside of the class, right? So normally you would not use P. Friend means this is actually not in the class. It's actually a global function. But I like doing it this way because if you think about it from a conceptual standpoint, the only it belongs here. You know, I'm saying what it takes to print a person to the screen. And so friend means it's a friend of the class, it's not part of the class. And so it's a function that takes an O stream as the left side of the double left arrow and a P on the right hand side. And so this basically says teach C++ how to print a person. Okay, and so it's going to print the name followed by a comma, a colon, followed by some of the data fields. And we crashed. Sweet. Oh, yeah, okay. So string $, is not going to work if you don't have any data. All right, so if we cat church, you'll see that this one, name, address, email, it's probably missing one of the, it's probably missing some of the fields, right? And so if you try converting an empty string, it won't work. So, okay, so if temp is an empty string, then p.ssn equals 0, else we'll convert it, and then we'll do the same here. So if temp is equal to empty string, then do nothing, else convert it to a number and add it. There we go. So let's get rid of this out statement here, and let's see if it's working. So Bill Kearney, address, email, phone, social, Aubrey, address, phone. It doesn't have an email, right? So there you go. So that's what you need to know to get Pokemon going. Okay, that's the process. That's the heart of the program. Open a file, make a class, open a file, read from the file, and make a bunch of people based on the data in the file. And then all there is after that is just searching through the vector to look up data and stuff like that. Can I put this in public? I can. Copy main.cc to public church of ucsd.cc. So there is the file. Instead of teaching C++ to print out the data, you could print out the vector. Yeah, absolutely. But one of the nice things is we can now do this. So we could say, for every const person by reference p in people. So for every person in people, see out the person. Makes it nice. Yeah, you could put all that here. But if you're ever going to print a person multiple times, just teach C++ how to print one out. There you go. And there's the vector. Okay. So there you go. That's more or less exactly what you need to know. And I'm sorry Pokemon's a video game, but the skills that you're learning from this, this is my bread and butter for getting paid like money, like in real life. You know, like you got data, you have data in some format, and you need to import it into your program somehow. And I just showed you how I would do it in C++. You have to import it. So you import the data, then you analyze the data, and then you output your analysis. 3 phases. Import data, process it, output something. And so for me, it was like, all right, let's find areas where we can improve, you know, AP testing. You know, if the students who are economically disadvantaged aren't taking the tests in great enough numbers, let's look at coming up with like fee waivers, you know, and coming up with ways that we can, you know, make it not be a barrier to low-income people taking AP tests so that they can pass the tests and then go to college and not have to pay as much in college, right? And so this is real life stuff, you know. So learning how to import data, and we haven't done any analysis today. Today was just importing, but it's permission denied. Nope. It's public. That's my script to make things publicly available. Okay, so yeah, hopefully that was useful. We didn't learn anything new technically today. Maybe the string stream stuff was new. Instead of the print function in class, you can create a normal print function. Yeah, you could. So, you could. That's just kind of I'm just showing you kind of the way that I would do it if I had to do this assignment. You can do it any way you want. It's up to you. All right, so thanks everyone. I'll see you on Friday, and we will continue more of this. Okay, see you then.